Okay, yeah, so we've done enough trig, so now we can start using it to do interesting things, and this is the first page of that. This page is all about how we can learn different pieces of sizes of circles using some trig information, and this is going to be a good link to converting between degrees and radians. If you need some review on that, this is a good section for that. And so, because quite frankly, the formulas are pretty easy, and so what I'm going to try to focus on during this particular talk is converting between degrees and radians and giving you some intuition about how to think about that. So the first equation that we're going to look at is this one right here, S equals R theta. And so S equals R theta refers to this picture right here, okay? And so we see that the radius is R, the length of the outside of the circle is S, and the theta value is on the inside here. And you can see what I'm underlining is that theta is measured in radians in this particular function, and this particular equation, I mean. And so when we use this equation, if we want to use this equation, we need to make sure that whatever our theta value is, it's in radians. And so that's like the only kind of tricky part about this page, is that you just need to remember that theta is measured in radians. And while we're talking about that, since it'll come into play in a second, I might as well just say something else about radians that we haven't quite made clear yet. Maybe I'll write it up here. Radians is not, I've been calling it a unit maybe, or maybe I've used the word unit. It's technically not a unit in the same way that like meters or degrees or, I don't know, any of those other things. Fahrenheit, kilometers squared, like those things are units as in they're a measurement. We use the word radians to differentiate between the inside of an angle like this that I'm pointing to right now and the outside of the angle on the unit circle. And so you'll see in a second that we need to make sure theta is in radians, but it's not actually a unit. And you'll see what I mean in just a second. So maybe I'll just write that down first though. So just note, radians are a label, not a unit. And so you'll see in a second what I mean by that, but you may just want to write that down so it makes more sense later. So radians are a label, not a measurement. Okay, or not a unit. Let's look at the first problem. So anyway, if we want to, this equation relates S, R, and theta, right? S equals R times theta. And so if we're given a question that looks like this, right, we're given R equals 5. We want to know the theta value, and we're given that S equals 10. And so this is our S. If we want to use this equation, we can just plug these two numbers right in there, and we see that S equals R theta, and so that means 10 equals 5 times theta. And so since we're measuring theta in radians, this ends up being theta equals 2 radians. And I mentioned I want to just kind of focus in on converting it. If we're interested in knowing this value in degrees, remember this is from the video lecture that I put up when I was away that day. If we want to figure this out in degrees, we take our 2 and leave some space here. I'm going to fill some stuff in, but we multiply it by 180 over pi. And let me just, I've said this before, and I said it in the video at least, but let me just sort of say it now that I'm in front of you, how you can remember 180 over pi. If we want this to be in degrees, we eventually want this to equal something degrees, right? This is the degree sign, right? And so the way you can think about that is pi comes with the label radians, 180 comes with the label degrees, and 2 already has the label radians. And so you can see that when we divide by this pi radians, it cancels this radian value as well, that label, and we'll be left with something that has a degree, which is what we want. Right? And then 2 times 180 is 360, and so this is the same thing as 360 over pi degrees. And so the second thing I want to point out, which seems to be a small confusion for people still, is don't forget that pi is a number. We just leave it as pi a lot of the times, but it's 3.14159 blah 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 blah, right? So this, we could actually divide 360 by 3.14 blah 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 and get an approximation for this. This is about 114 degrees. And I want to point that out because this kind of relates back to that homework question that talked about it gave you some angles or some radian values, and it wanted to know whether the value was obtuse, acute, or a right angle. That was a homework question from last time. And what I think the confusion of that question is that people are forgetting that pi is a number. And so if this is 0 on the unit circle right here, and we know that this is pi halfway around, that means this is 0, and this is about 3.14. Right? That 3.14 is pi. And so this picture makes sense because 2 radians is less than 3.14, but it's also bigger than pi over 2, right? Pi over 2 would be half of 3.14, which is like 1.8 something. So right here is like 1.5 something, 1.5-ish. 1.57, I guess. So if that's 1.57 because it's pi over 2, and that's pi, 3.14, then 2 is right in between them, right? And it's a little bit closer to 1.57 than it is to 3. And so I just wanted to remind you that pi is a number, and that's how you thought about that homework question. Were there questions about that one? That homework? I was emailing some people, so I thought I'd just say that out loud. So I just said a lot of things. Questions about any of it? The equation, converting to degrees, pi. All seems all right. Okay, so that one wasn't too bad. The next one's also not bad, but we just need to do a little bit more thinking. So this is the same kind of question, except we're not given a picture. So let's just draw the picture. If we have a circle like this, we're saying that the angle is 45 degrees and the radius is 10, and we want to find the length s. And so that would look like this then. Uh, 10 meters. And we want to figure out what s is. And again, the one time that people often misuse this equation is because you forget that theta has to be in radians. And so we're given it in degrees, and we need to think about it in radians instead. And 45 degrees is one of the easy ones because it's halfway between 0 and 90. And the radian value that's halfway between 0 and 90 is pi over 2. I mean pi over 4, excuse me. But just in case we didn't know that, we could calculate it anyway, right? So we need 45 degrees in radians in order to use this equation. And so we take that theta value, and we're going to do the opposite of what we did before, right? Before we went from radians to degrees, and so now we want to flip this 180 over pi and make it pi over 180. Right, so we take 45 degrees and we multiply it by pi radians over 180 degrees. And you can see why this makes sense, right? We want to end up with something that says something radians, because we're trying to convert degrees to radians. And you can see that these two degree values will cancel, and this radian value will carry over to the answer. Right, so that's, again, how you can remember these formulas. And so 45 goes into 184 times, and so this ends up being pi over 4, like we said before. You guys see what I'm saying about the formulas? It's just like anything else, I mean, in math, but specifically in the trig section, if we just kind of understand why this stuff works, we don't have to memorize things, because there's a lot in that section. If we just understand how it works and the relationships, they just like make sense, and they're just kind of in our head, and we can reproduce them. Rachel?
Maybe I'm missing something. I'm a little confused because why wouldn't you use that formula to solve it?
We will. We're going to use it, but in order to use this formula, theta needs to be in radians.
Okay.
And so we're just taking 45 and putting in radians first, and now we're ready to plug it into the formula. And so we want to find S, right? So S equals theta times R. Theta now is pi over 4. R is 10 meters. And so S ends up being, we can reduce 10 and 4, right? That becomes 5 pi over 2 meters. And so this is what I meant before by, let me make this a little more legible. That's a 5. It's 5 pi over 4, or 5 pi over 2, I mean. Did I just make it worse? I don't know. This is what I meant before about radians not really being a unit. They're kind of just a label, it turns out. So even though pi over 4 had the unit radians, it was just a label, and the label we use on this one is meters, because meters is what 10 was measured at. And so we don't actually include the radian value on that. Questions? All right, do this last one then. So this last one is asking to do both those things, right? So we're given a circle. Let me just draw the circle. The circle has a radius of 5 meters. And we're given the S value. We're given S of 6 meters. You guys see that okay? And we want to know what theta is. And we're being asked to show it in both degrees and radians. So you want to use this equation and solve for theta, but then that theta value is going to be in radians, right? So you'll do like ... you'll get theta equals something in radians, and then convert this into degrees. You want to convert that in degrees by multiplying by 180 over pi. Questions? Does that sound okay? All right, let's take a minute and do that. Bring around test topics right now. Questions? Yes, but that's a radian value, so 6/5 radians. So that's half the answer. If we want degrees, we multiply that by whatever it is here. To go from radians to degrees. So notice how this was one from radians to degrees. This was degrees to radians, so that was what? What I was trying to point out before is it makes sense this way because this radian, this rad, literally those three letters cancel those three letters. So that's why that makes sense. And the opposite is true in this, right? The degrees cancel left with the radian. General stereo. All right, let's take a look at this one. So we've got an S value and we've got an R value. All right, so we can plug those in. This becomes 6 equals 5 times theta. And so then when we solve for theta, we get 6/5. Right, and so 1 1/5 radians is what that ends up equaling. Yes. Sorry, got scared that wasn't right for a second. That looks good though. So that's the radian value. And we know it's the radian value because when you solve this problem, you get theta in radians, right? That's what the top says. And if we want to change it to degrees, we take that value, 6/5 radians, and we multiply it by 180 degrees over pi radians. And again, the way you can remember the order of this fraction, just in case it wasn't clear, right? This fraction is the reciprocal of this fraction. This one goes from degrees to radians. This one goes from radians to degrees. And we can know which way the order is because the radians cancel here. And we end up with a degree value, right? So when you multiply 6/5 by 180, you might get 216 over pi. And we could divide that if we wanted to, and that would be approximately 69 degrees. And that makes sense, because 1 1/5 radian is less than pi over 2, and 69 degrees is less than 90. And so those two things seem to fit that picture and fit with each other. So that's good.
Same answer, but went the entirely different way.
How did you think about it?
I figured out what times 5 equals 6, which I got 1.2. And then I did 1.2 over 1 times 180 over pi, getting 216 over pi.
Yeah, so when you thought about what times 5 equals 6, you just solved this equation in another way other than dividing by 5, which is just as good. That's fine, but just know it can be hard to think about that sometimes. If it wasn't a 5, like if it was a 7 or something like that, that could be more difficult to think about. And so just note that dividing that over gives you the same thing too. But yeah, that's great. Other questions or comments? All right. Yes?
Would we have to do like 216 divided by pi like on the test?
I'm okay with leaving it like this. I'm just trying to make it something that's more familiar. And really trying to just drive home that pi is a number. Please don't forget that it's a number. It is a number. And so we can get a number out of there. But yeah, I'm fine with leaving it like that. I like this answer. And that's a more exact answer, right? When I wrote 69 degrees, I wrote these squiggly equal signs, which meant that I was rounding. And so this is not rounded. That's actually a nicer answer, in my opinion. But I just wanted to be clear what's going on there. Other questions? Okay. So that's one formula that we can use. Again, let's compare this one to the next one, because this one relates the radius, the length of the piece on the outside, the arc length, excuse me, and the angle. And the next one relates the angle and the radius again, but now we're calculating the entire area of that slice instead of just the outside piece or something like that. And so we have the same values of r and theta being in radians, so please let me just write that down again. Theta is in radians, please don't forget that. But this time we've got a formula that relates it to the area. And so we'll do kind of similar things on this one, except we're dealing with the area. So let's see what we got here. So we've got a couple pictures. Let's find the radius of each circle if the area is 12. So on both these pictures we've got a equals 12. And we want to know what the radius is. So I'll just write in r here. We don't know what r is on either one of those, but we have a formula that we can use to solve it. What's the difference between these two pictures? What's the one thing we need to do differently in the two of them? Good. So the one on the left has a radian measurement. So this one's measuring the outside of this circle, the distance from one to the other, that is. And the other one is measuring theta, theta on the inside, which is 150. So it's measuring the degrees that are going on right there. And so on the second one, if we want to use this equation, we need to change it 150 into radians. That's the only difference between these two. The first one's not bad though. So if we want to solve for r, we just plug it into this equation, and we have 12, because that's our area, equals 1/2 r squared times 0.7 radians. And we can just use the equation as is because we have a radian value. And so just see what happens here. I'm just going to jump to the answer, but we multiply by 2 here, right? This would give us 24. And then we divide by this 0.7, so we'd have 24 over 0.7. And then we'd take a square root. And so we'd have r equals plus or minus square root of 24 over 0.7. And so this is approximately plus or minus 5.86. That doesn't sound right. Oh, that's probably right. Yeah, I'm sorry. That sounds right. So we get two answers, right? Because we took a square root. But what's the answer we want? The positive one. Why do we not want the negative one?
Because it's squared.
Adrian?
It makes no sense for it to be negative.
Say more. It doesn't make sense to be negative because
Because like it's going like I checked it off. Like,
what is the value for? It's for the radius.
Yeah.
it's positive.
So we can't have a negative length, right? Negative lengths don't make sense. Radius, this is a length measurement, and so minus 5.8 length is not true. And I know you guys are both saying that. I was just trying to get you to be a little more careful about it. Anyway, so we do r equals positive 5.86 because you can't have a negative length.
But also because it's squared, right?
But
No, I'm sorry.
you see what you mean, yeah. I heard you before, but I was like, oh, you could figure that one out. Yeah. We get the 2 because when you square it, it comes out. Yeah. Okay, that one's fine. The other one, very, very similar, but we're given 150 in degrees. And so this will be the last time that I kind of drive this home, or trying to drive it home. If we want to take 150 degrees and we want to get something that says radians, then we need to cancel the degree and give us a radian. And so that means we want to multiply by pi radians and divide by 180 degrees so that the degrees cancel and the radian sticks with us. Should have given myself a little more room here. This is actually one we know about, right? 30 goes into both 150 and 180, and it goes into 150 5 times, and it goes into 180 6 times. So this one actually is a familiar point. Didn't give myself enough room here. This is 5 pi over 6 radians. So that's one that's actually on the unit circle that we're familiar with. And so instead of using 150 in the equation, we just use 5 pi over 6. Right, but it doesn't carry any units with us, and so we don't use that unit. So anyway, we have 12 equals 1/2 r squared times 5 pi over 6. Again, I'll let you think about the algebra here, but we would multiply the 2 over to get 24. We multiply by 6. That would give us 144. And then we divide by 5 pi that is, and so we'd have 144 over 5 pi equals r squared. And so that means r equals, I'll do the same thing again, 144 over 5 pi. We get plus or minus again, because we took a square root. We only want the positive one, and so we just take the positive one. Right, what does a negative radius look like? I don't know. It doesn't look like anything. It's not real. Okay. Give the last one a go, unless there's a question about that one. Last one's very similar, and you're going to get to convert from degrees and radians again. You're just not given a picture, right? So we have an area of 10, so we were given a equals 10, and we're given that radius is 2. And so plug it into the formula, find one, convert it to the other. questions? Other questions?
I think this is for.
It's another board. They just painted over some kind of board.
Yeah, it does look like it used to be a board. There's one over there too.
Yeah. Maybe they're all working this room. Because that looks like a wall divider.
Maybe it's.
You know how every time we come in here, the tables are all moved? You know why that is? They do like dancing.
Really?
I swear to God, I was with Justin one time. His room's right there, and he looks in here, and there's a bunch of people dancing in here. I'm like, oh, that's what I do.
That's weird because the dance studio is literally right underneath this room, I think.
And it filled up, I guess.
Oh, it's the overflow dance room?
It was like not real, it was like Cotton Eye Joe stuff.
Okay. Not a real dance crew then. Anywho's, let's look at this one. So we plug these in, we get 10 equals 1/2 times 2 squared theta. And when we go ahead and solve that one, right, we get 20, and then we divide by 4, and so we'll get 5 radians equals theta. And then if we want to change that into degrees, we want to cancel the degrees, cancel the radians, give it degrees. So we take the 5 radians, we want to divide by pi rads, because those will cancel, and then we want to give it the degrees by multiplying by 180 degrees. So these guys cancel, and this becomes something. I've got an approximate answer. This is approximately 286.5 degrees. And again, that should make some sense, because 5 all the way around the unit circle is 2 pi. All right, let's think about that real quick, just to be clear. That's t equals 0 and 2 pi in radians, and it's 0 and 360 degrees in degrees, right? And so 5 radians is almost 2 pi. 2 pi is, right, that's 6.28 about, right, pi times 2. So 6.28 is pretty close to all the way, 5 is pretty close to all the way around, and 286 is pretty close to all the way around in the other sense. Anyway, just trying to relate that stuff all together. Any questions about that? Okay.